Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as Assistant Professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Welcome in the topic on the thermodynamics, in which we have started the part related with the thermochemistry. And in that, we understood in the thermochemistry, we basically study the physical and chemical changes which are associated with the system. And based upon that, we can say during a particular chemical process, either heat is absorbed or heat is evolved. In that, we have seen how to calculate the enthalpy of a reaction or heat of a reaction. That is nothing but delta H, and that is nothing but the difference between the enthalpies of product, that is HP, minus enthalpies of reactants. So based upon that, we can calculate the delta H, that is heat of reaction. Then in the next part, we have seen how to calculate the heat of formation. So heat of formation can be calculated from its constituent elements. So these are the topics we have seen in the earlier part. So in this particular session, we are basically going to see the enthalpies of formation. Along with that, the enthalpy of combustion, dissociation energy and resonance energy. So let us see first concept, that is enthalpy of combustion. This particular concept already you might have learned in your earlier classes. So enthalpy of combustion. So as we know the process of combustion, what is meant by combustion? It is a process of burning any particular compound in presence of air, or we can say in excess air. So the standard enthalpy change which is accompanying a reaction in which one mole of substance is completely burned in excess air or oxygen, that is also called as a standard enthalpy of combustion. अगर कोई भी सब्सटेंस हम एक्सेस एयर में और इन प्रेजेंस ऑफ ऑक्सीजन बर्न करते हैं, so whatever the heat is given out from that particular reaction, that is called as a standard enthalpy of combustion. We have in the last session we have seen the concept of standard state. So what is meant by standard state? It is being a concept given by the IUPAC system. So based upon that, we can say we have to follow the standard condition. So in terms of parameters, the temperature must be 298 Kelvin, that is 25 degrees Celsius, and pressure must be 1 bar. So these are the standard states. So if we see the standard enthalpy of combustion, जब हम कार्बन बर्न करते हैं at 298 Kelvin, so it's delta Hc. Delta Hc is nothing but what? The heat of combustion at standard state. That is also called as the standard enthalpy of combustion, and that is nothing but minus 353.5 kilojoule per mole. So this is a value. So if we see another example, suppose there is a ethane. If we burn ethane in a presence of excess air, so it will form carbon dioxide and water. Let us see this particular reaction. So this is the ethane, C2H6. If it is burned in presence of excess air, it will give out carbon dioxide and water. So this is nothing but the enthalpy of combustion, minus 1560.1 kilojoule. So what the minus sign indicate to us that during this particular reaction heat is given out. So this is an exothermic reaction. Whenever we most of the combustion reactions are having negative values of their standard enthalpy of combustion. So we have to understood that the negative sign in which we have to see that particular reaction is exothermic, means the heat is given out. So basically, what is the application of enthalpy of combustion? What basic thing we can study when we know the value of enthalpy of combustion? First thing is that based upon the enthalpy of combustion value, we can calculate the enthalpy of formation of any particular compound, because it is not always easy to carry out reaction of a compound which is formed from its element in stable state. Therefore, heat of combustion is used to calculate heat of formation in such cases. It is very difficult to calculate the value of heat of formation. हीट ऑफ फॉर्मेशन की जो वैल्यू होती है वो कैलकुलेट करने में बहुत परेशानी होती है. सो इफ़ यू नो द वैल्यू ऑफ कंबशन, how to know the value of combustion? Take the compound, burn it in excess air. So whatever the value you will get, that particular value will be equal to the heat of formation. Okay, so this particular value will be utilized to calculate the value of heat of formation or enthalpy of formation. Then we can also calculate the heat of formation of different allotropic forms. Okay, suppose allotropic forms means what? Suppose we will take the example of carbon. As we know that carbon exists in two forms. It may be either diamond or graphite. So these are the allotropes. So if we know the value of heat of combustion of this particular allotropic forms, then we can also explain its heat of formation from its heat of combustion value. So we can calculate the heat of formation of allotropic forms such as carbon. Then next one is application of enthalpy of combustion का जो application है, we can determine the calorific value of fuels. जो भी fuels रहते हैं, fuel मतलब क्या है कि this is any particular compound which when being burned it releases energy. So basically every fuel has the efficiency value. As we know the methane, ethane, butane, when these compounds are burned they give out different values. So that is being called as a calorific value. I will repeat, calorific value is directly related with the efficiency of that particular fuel. Petrol ki value, diesel ki value, that is different. Okay, so efficiency of fuel can be compared by determining their standard heats of combustion. So if you know the value of heat of combustion, based upon that we can calculate the calorific value of any particular fuels. See this particular table. Here are the compound and on this side there are the values. Suppose if we take hydrogen, what is heat of combustion value? Minus 286. For methane, minus 889. So as you go down, you can see propane is having quite higher value, minus 2220. So these are the heat of combustion value. So all these compounds are acting as a fuel because they released energy when they burn in excess air. If you see the values of heat of combustion, all the values are negative. सब values जो है negative है. So what is the indication of that? This particular fuels release energy when they are burned in air. So it is a exothermic reactions. Then the next concept is dissociation energy. Dissociation energy मतलब क्या कि कोई भी अगर कंपाउंड है उसके बॉन्ड ब्रेक होते हैं, सो दैट कंपाउंड गेट्स स्प्लिट अप इनटू द इट्स कंस्टिट्यूएंट एलिमेंट. सपोज अगर हम एग्जांपल लेंगे वाटर का, तो वाटर में हम लोगों को पता है कि ऑक्सीजन इज इन बिटवीन सेंट्रल एंड हियर इज द हाइड्रोजन एट वन साइड at another side. So these are the two covalent bonds. When these two covalent bonds breaks, so it gets split up. When H2O gets split up, we get two molecules of hydrogen and one molecule of oxygen. So that is called as a whatever the energy released, that is nothing but dissociation energy. Okay, so let us see the definition. It is the definite amount of energy released whenever chemical bond of certain type is formed. So on the other hand, certain amount of heat energy is absorbed at the time of bond dissociation process. Former is exothermic in nature and latter is endothermic in nature. See, whenever any particular covalent bond or any particular bond is formed, the energy is being released. And whenever release means what is the endothermic process. And when we want to break that particular bond, we need to absorb energy. So that is the endothermic process. Remember this terminology. This will help you to study the dissociation energy. So remember, bond dissociation energy is defined as the average amount of energy which is energy absorbed per mole of bond breaks a particular bond present in a molecule into its constituent atoms in the gaseous state. Remember, you have to consider the bond dissociation energy. It is nothing but the energy released when one mole of particular bond get breaks for per mole, we have to consider for 1 mole of molecule. So whatever the bond get breaks into its constituent element, already I have explained with the help of water. Suppose there is a hydrogen molecule. So this particular hydrogen molecule is having, it is a homoatomic molecule having same, homo means what, same atoms, HH. So HH gets split up into HH in the gaseous state. Remember, you have to consider this particular dissociation energy only in the gaseous state. Suppose if we take this particular hydrogen is having dissociation energy this much, 435.136 kilojoule. If we take for the water, so what will happen? Water, it will first break up one particular covalent bond between oxygen and hydrogen. So it will dissociate as H and OH. So this much amount of energy is being absorbed. It is having plus, so that's why I am saying absorbed. It is the endothermic process. OH, again this particular OH bond will break. So you will get two elements of hydrogen and one oxygen. So this is the amount of energy which is being released whenever particular bond get dissociated. Remember what is meant by dissociation process? It is nothing but splitting of particular bond or breaking of that particular bond, and as a result of that you will get constituent or single elements. Then the next concept is resonance energy. Okay, so this particular phenomena is basically applicable for the aromatic compounds. For example, benzene, naphthalene, anthracene. As we know that in case of the benzene, we can write the different or two structures for the resonance, because these two structures are resonating structure. Resonating structure means what? They are same structure but only they differ in the position of carbon-carbon double bond in them. Okay, so जो भी pi electron रहते हैं benzene के, that are continuously moving, or we generally say that they are delocalized. Delocalized means what? वो एक जगह पे नहीं रहते, हमेशा घूमते रहते. So as a result of that, they will form a ring current, that is due to the circulation of pi electrons. Okay, so due to this delocalization of that the p orbitals are continuously in the cyclic manner. Okay, so basically resonance energy is applicable for the compounds like benzene because they are having resonance hybrid structures. These are the resonance hybrid structures. So if we see, in order to see the heat of formation for the benzene, it is observed 256 kilojoule. If we on the paper, if you want to calculate how much is the heat of formation based upon the carbon-carbon single bond, based upon the carbon-carbon double bond present in the benzene ring, we can calculate as per the Hess law. It is 256 kilojoule. मतलब हम लोग क्या बोल सकते हैं कि बेंजीन बनने के लिए 256 किलोजूल पर मोल एनर्जी लगनी चाहिए, but it is observed that it is only 82 kilojoule is required. So what we can say, there is a difference of 173.1 kilojoule value. So there are two values, one is calculated by using Hess law and another is observed. So observed is quite lesser as compared to the calculated. Why? Because of the resonance hybrid structures or delocalization of pi electron. So the resonance energy, we can say it is a difference between calculated value and observed value. We have to remember. So calculated value is how much? 256 minus 82 is equal to 173.1 is equal to the resonance energy. Therefore, we have to consider that there is a difference in molecular energy between resonance hybrid and most stable resonance contributor. So in general, we can say the stability gain by energy delocalization due to the resonance versus such a delocalization. So remember, resonance energy we can interpret for the benzene molecule or naphthalene molecules because of their resonance structures. So I will repeat again, resonance energy is nothing but a difference between calculated value and observed value. So go through this particular part. In the next part, we will see some more terms related with the thermochemistry. Till then, thank you very much.